Exploring power electronics, the future of energy conversion. Hello everyone, welcome back to our channel. In today's video, we're diving deep into the fascinating world of power electronics. Whether you're an engineer, a student, or just someone interested in the technology that drives our modern world, this video is for you. From renewable energy systems to electric vehicles, power electronics plays an essential role in the way we generate, convert, and utilize electrical energy. Let's break it down into digestible segments, exploring what power electronics is, why it matters, and where it's headed in the future. What is power electronics? First up, what exactly is power electronics? Power electronics is the technology that deals with the conversion and control of electrical power. This involves converting electrical energy from one form to another, think AC to DC, DC to AC, or voltage levels, and managing that power efficiently. At its core, power electronics revolves around devices like converters, inverters, and controllers, which work together to control power flow. The heart of these systems can be found in components like transistors, diodes, and capacitors. Why does power electronics matter? So, why does power electronics matter? Well, the importance of power electronics can be seen across numerous industries. It's crucial in 1. Renewable energy systems. Power electronics facilitates the integration of solar panels and wind turbines into the electrical grid, converting generated power into usable electricity. 2. Electric vehicles, EVs. Power electronics manages energy flow in EVs, handling everything from battery management to motor control. 3. Consumer electronics. Devices like chargers and power supplies rely on power electronics to operate efficiently, improving battery life and reducing energy consumption. Applications of power electronics. Let's take a closer look at some of the applications of power electronics. 1. Solar power systems. Solar inverters convert the DC electricity generated by solar panels into AC electricity used by the grid. They also optimize energy harvest through maximum power point tracking, MPPT. 2. Wind energy systems. In wind turbines, power electronic converters help in stabilizing grid demand by adjusting the output from the turbine based on wind strength. 3. Electric vehicles, EVs. Power electronics governs the operation of EV motors, ensuring smooth acceleration and regeneration of energy back to the batteries during braking. 4. Industrial drives. Power electronics regulates motor drives in manufacturing processes, offering enhanced control over speed and torque, which enhances efficiency. 5. Smart grids. Power electronics are pivotal in smart grid technology, allowing for real-time management of electrical power and improving the overall efficiency and reliability of the power system. Types of power electronic converters. Let's explore the different types of power electronic converters, as they each serve specific functions. 1. Rectifiers, convert AC to DC. Think of them as the first step in powering your phone or laptop. 2. Inverters, convert DC back to AC. Vital for connecting renewable sources to your home grid. 3. DC-DC converters, change the voltage levels of DC power. They're essential in EV battery management systems. 4. AC-AC converters, change the frequency or voltage of AC power. They're widely used in industrial applications. Challenges in power electronics. Despite its incredible potential, power electronics also faces some significant challenges. 1. Thermal management. High power densities can cause overheating, making effective thermal design crucial. 2. Efficiency and losses. As devices become more compact, designers need to maximize efficiency while minimizing losses. 3. Reliability. Components must withstand harsh operating conditions to ensure long life, especially in renewable applications. Future trends in power electronics. So, what does the future hold for power electronics? Here are some emerging trends to watch. 1. Wide bandgap semiconductors. Materials like silicon carbide, SiC, and gallium nitride, GaN, promise higher efficiency and better performance in high-temperature applications. 2. Integration of power systems. Greater integration of power electronic systems, such as solid-state transformers, will create smarter and more flexible electrical networks. 3. Renewable energy growth. As the world shifts to more renewable sources, the importance of advanced power electronics technologies will only escalate. 4. Electric and autonomous vehicles. The demand for efficient power electronics will increase as the automotive industry moves toward more electric vehicles and innovations in automation. Conclusion. To sum it up, power electronics is at the forefront of energy innovation. From supporting green energy to enhancing electric mobility, it is a field packed with potential. If you're curious about a specific topic or want to learn more about components or applications, drop your questions in the comments below. Thank you for joining us in exploring power electronics today. Don't forget to give us a thumbs up if you found this video informative and subscribe to our channel for more engaging content. Until next time, stay curious and keep innovating.